Today we are going to do section 2.2, part 1, and where we'll cover the homework section. But before I do that, I want to again emphasize on how important this solving equations section really is. It is important for you to learn this thoroughly as you can, so that you have a good grasp of it. Now, if you do have a good grasp of it, of course, that's not a problem. But for those who don't, I would like you to read this part of the Harry Potter book, this is from Half-Blood Prince, where Dumbledore was talking to Harry about doing something, okay? Dumbledore says, well, Harry failed at first, so Dumbledore says, do you feel that you have exerted your very best efforts in this matter? Have you exercised all of your considerable ingenuity? Have you left no depth of cunning unplumbed in your quest to retrieve the goal? So that's what I want you to ask yourself when you're handling this section if you are not 100% comfortable with it. Okay, so that is give it your best Dumbledore try. Okay, and after that, then it's okay. If that's the best you can do, you can just come back and refer to it every time you run into trouble in the future. But at least give it a good, honest try. So having said that, let's start with problem number 7. Okay, a quick short one where we have 4x. Problem 7, we are now on page, let me write down the page first. This is page 112. Homework on page 112. Let's first look at problem 7, which says, start with a short one. We have 4x minus 3 equals to something like 5. Okay. Now, the first step, our goal, as always, to isolate x on one side of the equation, which means we'll kick everything else somewhere else. And well, specifically to the other side. For things that are plus and minus, we kick it to the other side by reversing the sign. So then I'll write down the 5 here. And then the minus 3 will become plus 3 once it gets kicked over. And so we have 4x left. And the next step is that now 4 is being multiplied to x. Now to take care of anything that's being multiplied, doesn't matter if it's 4 or a billion, we will push it down across the equal sign to the bottom of this thing. So right now we have, right here, we have 8, okay? 8 is the same as 8, we'll draw a division line on it and push the 4 down to the bottom. Okay, this is like this is a type of cross multiplying. You see, you're crossing it, and but in this case, we're just kicking it down. Okay, so then x equals to 8 over 4. Is that right? Yep. Which is 2, and that is the answer. And once we found that, let's check the answer at the back, which does seem to be correct, and then we're good. So that's problem number 7. Next, let's look at problem number 9. Problem number 9, we have, let's see, okay, we have 12 minus 5 times x plus 3 equal to 2x minus 5. So to do problem number 9, we always first solve the parentheses and get them out of the way, because they demand precedence. Okay, the word means do me first is what that means. So we're going to do that. So we'll write down the 12, okay, and then we'll take the 5, and the minus or negative sign in front of there, they're the same thing. The minus sign in there is attached to it. So we'll take this, will count as negative 5. Okay, so we'll take negative 5 times x, we'll have minus 5x. And then negative 5 times positive 3 is minus 15. And that will be equal to, this hasn't changed yet, so we will write it down. Now, by the way, if you are good at this section and did all the homework without really needing any help or referring or anything like that, and got the right answer, except for small mistakes, you know exactly how to do it, you don't need to go through the answer section, okay? Please skip it, don't waste your time, and then move on to the next section. But if that is not the case, if you had certain trouble or if there were things that you weren't sure and you needed to look out, then please stay with this video and go through the whole thing, because I will explain everything in great detail to emphasize on how important this section is, okay, for those who doesn't have it completely down. Okay, so let's continuing. We have this thing now. First thing we do is focus on the x's. What's with the x? So there's a minus 5x and a positive 2x. So let's move everything over here, because anytime you kick something across the equation line with plus and minus, you just flip the sign. That's true with numbers or stuff with x's in it. So this will move the 5x over here. That becomes plus 5x. 5x. And then the 2x is still here, which is a plus. Okay? If there's no symbol, that means it's a plus. So that we have 5x, and so we took care of the 5x and the 2x. Now next we have 12 minus 15. Okay, so 12 minus 15 is negative 3. And then over here we have a minus 5, so we'll kick it to the other side by flipping the sign. That will be a plus 5. So, and finally 5x plus 2x is 7x. Actually, it's not finally yet. Okay, we'll have one more step. Minus 3 plus 5 is positive 2. And then, so then to get rid of the 7, we need x, just x, okay, by itself. So get rid of the 7, we'll push it down through the, across the equal sign and push it down to the bottom of the denominator. And like this. So that would be the answer. That's number 7, no? What problem is that? Number 9. Is that right? Yep, it is, which is always great when you get the right answer. Okay, and that's the fun part of algebra, is when you get it right. So next, let's do problem. What am I doing? 9. Okay, next problem 11. We'll write it over here. Problem 11, which states that what does it say? Okay, I will write it down here. Problem 11 says that we have x over 3 minus 3 over 4 equals to something, 2x plus 3 over 12. All right. So here we have a fraction, and when it comes to fractions, it has an easy least common something, multiple or something. Anyway, so we have 3, 4, and 12, and we want to get rid of the denominator if we can, because they're kind of a pain, right? And in this case, we're going to multiply by 12. Okay, we'll say multiply. Let's not use the x symbol. Let's get rid of that. Just write down. We'll multiply everything by 12. Okay, so I'll write down multiply by 12. All right, so multiplying everything by 12, then we get 12x over 3, okay, and minus 12 times 3. The dot means multiply, okay, 12 times 3 over 4, and then we have to multiply by 12 both top. Excuse me. Let me. Now, sorry about that. I got confused for a moment there. What I meant to say is not multiply by 12, but make all the denominators 12, right? I want everything to be 12. Now, to become 12, we have to multiply 3 times 4. So this is 4x. And the reason you know it's 4x, because if you cancel out the 4, you get the 3 back. So similarly, we have, we'll write down 12 here. And to become 12, you have to multiply by 3, so it's 9 here. Okay, again, when you cancel out the 3 in this expression, you get that one back, so then we know the equation still holds. And this side doesn't have to change. And that is our answer, our situation. So now the denominators are all the same. Now, once the denominators are the same, then we have the numerators are the same too. So we can just ignore the denominators, okay, and write down the equation that the numerators are the same. So 4x minus 9 equal to 2x plus 3. And then now we will use the same trick. We will move this thing over here because 4x is over here. So we'll move this to this side, and that becomes a minus 2x. And then 4x is still here. okay? And then we'll move the minus 9 to the other side. It becomes a plus. So it becomes a plus 9. You don't have to write down the plus 3. So then we have 4x minus 2x. That gives us 2x, and it equals to 12. And then, so that means x equal to 6. And that is, that should be our answer. What is that, problem 11? Yep, x equal to 6. So that's great. Now, next, let's do problem 12. I'll do it right here, which says that 2/3 x plus 1/2, okay, equals to something, equals to 31 over 6. This is an equal sign. There. All right, now how are we going to pull that off? Now we have, at this point, we have only one thing with x in it, okay? There's, you can do something like that with a common denominator if you want, or we can just get rid of that basically. So we have 2/3, let's not get rid of it. That might get confusing. We'll do the same thing we've done before to be consistent. But there's more than one way to skin the cat. So whichever way you do it, that's correct. That comes out with the right answer is good enough for me. Okay? But for now, we will do the same trick we do here. Now to write things like this is the same as, this is the same thing as 2x over 3. Okay? There is no difference. Now we are going to change it to 6 because we want everything to be the same denominator. Then we can get rid of it once everything is the same. So then to become 6, then we have to multiply by 2. Okay, so then this thing cancels out to look just like that, right? And then for 1/2 to have 6, then we have to turn it into 3. And then the other side, of course, is 31 over 6. Did I get this right? Does it really say 31? Am I doing problem 12? Oh, sorry. Problem 12 isn't part of the homework. I forgot. I'm supposed to do problem 13. But since we started, let's finish it, okay? And so we have the top then now is lined up. So this becomes, we'll ignore the denominator at this point, okay? So then we have 4x. Once the denominator is the same, then you can just ignore it. And then, so we have 4x plus 3, that's a plus sign, equal to 31. That's because, once you have the same denominator, that means the numerator will add up to be the same, right? And so then this will be, so 4x, move the 3 to the other side, becomes a minus, okay? So it becomes 31 minus 3, that's like 28, okay? And that gives us, so then x will be equal to 7. When you, the x equal to 20, push the 4 down to the bottom of 28, like this. Oops, let's see. Okay, push the 4 to the bottom of 28, 4, okay? And that would be equal to 7. That's 28 divided by 4. And that's problem 12. Now I will now move on to problem 13, the problem that we were supposed to do, by first erasing my board. Next, let's do problem 13. I have it written down right here. Now, we do the same thing as we always done. Now, first we need to get rid of the parentheses. So we have 3, okay, multiplied by 2 things out here and only 1 thing in outside. As always, when that happens, this is a guy and these are 2 guys in the same group. And you're going to multiply this by taking the first guy and multiply and shake hands with every guy in the group, one at a time. Okay, so first, we'll do 3 times 2x, so that is 6x. The first handshake. 3 times minus 1, minus 3, that's a second handshake. And then plus x, we'll write that down. Plus x equal to 5x plus 3. So the rest of it doesn't change. Now, secondly, we are going to move the 5x onto this side, okay? Because there's more positive x's on this side, and I like x's positive. However, it doesn't really matter which side you move it, okay? Just move all the x's into one side and move everything else to the other side so you can do the division and isolate x. So first but for now, I want to move x's to this side. So we have 6 plus 1, so we have 7x, okay? Move the 5x over here. The positive 5 becomes minus 5x. So far we have taken care of that, and that. And next, we have a minus 3 here. We'll move it over here to become positive 3. Okay, anything moved across the equal sign, you just flip the sign and then it's good. Okay, anything that's plus or minus. So we come positive 3, here's the other positive 3 here. So we have, this side has just 6, this side has 2x. And at this point, being that its number are being multiplied, then you move it across the equal sign by pushing it down below the division line. This is the division line. Push the 2 down like this, 2. Okay, x is still here, and that is your answer, which is 6 over 2. 6 divided by 2 is 3. Because remember, this is just the division lines. It means 6 divided by 2. Fraction and divisions are the same thing. So that should be our answer. And let me check. Yep, it is our answer. Isn't that awesome? Always great to get the right answer. And it's very satisfying. Okay, but if you don't get the right answer, just double check your work to see if you maybe forgot to flip the negative 3 to become positive 3, or maybe you forgot 3 times 2 is 6 and it's not 5, that sort of thing. Just double check your problem if you get it wrong to see where you got it wrong and where you made a small mistake. That's usually how you get problems like this type of thing wrong. And next, let's work on problem 15. Problem 15, which we have, let's see, problem 15. Okay, so should I write it down here or over there? I guess I'll write it down here, it's fine. Problem 15, okay. So problem 15, we have this situation going on where we have a 4 here and a 3 here. So we're going to use the least common multiple, I think it's called, and which is 4 times 3, which is 12. So we are going to make all denominators turn into 12. Okay, everything will become 12. So how are we going to do that? So let's write it over here. To do that, let's see. So we have x plus 2. Okay. And then, but we need this to be 12. For this to be 12 and yet equal to that, we have to multiply by the top by 4 times 3 is 12. So let's multiply it by 3. See, if you cancel this stuff out, it will become this again. And that's how you know you have done correctly. And next, we'll write it down x minus 1. And then again, this is 12, but how did it become 12? We need to multiply the top by 4 because 3 times 4 is 12. And now this will cancel out to be this exact thing. So we're still doing good. And finally, for the bottom to be 12 here, that would be the top, it has to equal to 2. So then the top has to be 24 because 24 divided by 12 is 2. Okay, so then everything works out. And so now that we have it worked out okay, let's continuing. Now that we have denominators are all the same, right? We can just ignore the denominators and focus only on the numerators, because if the fraction, that means the numerators all work out. So we have we have x plus 2. I'll rewrite it here, times 3, minus 4x minus 1. It's just a habit of writing the number in front, okay? And that will equal to 24. All right, so let's multiply this stuff out. So again, you start with one item and multiply each one that's in the second group. And that's true here too. Well, you think, well, how would I do this? Then you start with each item here and multiply by everything on this side. Well, there's only one thing here, then you just multiply by that, okay? And then go to the next one. So your first group, and then there's the second group. So, but anyway, so here's my group. I have 3 times x, okay? Multiply with the first guy. So we have 3 times x, and then multiply by the second guy. So that's 3 times 2 is 6. And then that's the negative 4 stays with the 4. The negative sign stays with 4, okay? So it's minus 4 times x. So that becomes minus 4x. And then minus 4 times positive 1, which become positive 1. Same signs become positive, different signs become negative. okay, during multiplication. So that's how I got this, and this side doesn't change, it's still 24. And the next step, we do 3x, okay, minus 4x is negative x. So we'll write that right here, negative x. From 3x minus 4x, so we have minus x left, and then we have plus 6, okay, and then plus 1, that's plus 7. Now remember that we have plus 7, but we're going to push it to the other side and turn it into minus 7, okay, and the 24 is just a plus 24. Without a sign means it's positive. So what does that equal to? That equals to negative 27 or something, yeah. So then, so minus x equal to minus 27. At this point, we'll push the minus sign, which is just minus 1, to the bottom of this thing. Okay, same as always, because we want positive x only. So if you push this to the negative sign over here, 27, the negative sign is the same as negative 1, so x equal to just 27. Alternatively, you can also cancel it, okay? Just cancel the negative signs out to become positive. Either way, it's gonna work. But this is what we've been doing, okay? Just push things that isn't x right to the bottom of the division line, and then you do the division, and that is the value of x. For what problem is this? Is problem 15. Let me see, did I get it right? Minus 14. No, I have a mistake in here. Let me double check to see where I messed up. You see, I found one mistake right here. See, it's minus 4 times negative 1. What is that? It's not positive 1, it's positive 4. Yeah. So here we go. And then, so then what we have, this is plus 4 and plus 6. That would be 10, right? So that would be minus 10. Let's see, yes. Minus 10 plus, why do I have plus 34 here? It's 20. Yeah, isn't it 20? Yeah, it says 24. I don't know why I wrote down 34. So then let me erase the rest of the mistakes. So let's continue. Now I have, so the other stuff are okay. See, my biggest mistake is I did the minus 4 times minus 1. I wrote down plus 1 for some reason. It should be plus 4, right? And then now things look much better. So continuing, we have 3x minus 4x still minus x, but we have plus 6 plus 4, that's plus 10. Push it to the other side, that becomes minus 10. Okay, so then we have and then minus 10 plus 24 is minus 14. And that actually is the right answer. Now, isn't that awesome? Yeah, you say, well, but you know, messing up is no fun. It isn't, and for me, I do make this kind of mistakes a lot, ever since I was a kid, okay? But it's still, you can still enjoy math. If you do make mistakes like me, hopefully you don't, but if you do, it's still okay to enjoy math. If you make a mistake, just fix it. It's no big deal. Okay, and so next, let's do, what's next? So next, let's look at problem 17. We have a situation where x is on the bottom. However, we have the benefit of x. This x on the bottom looks identical, okay? So we don't have to work too hard to find some common denominator that might be a real pain. So this is a fairly straightforward way of doing things. Now, the first thing I should mention is that anytime you see x is on the bottom, you have to emphasize on the fact that the denominator cannot be 0. That is, x plus 4 cannot be 0, okay, because it is not possible to divide by 0. Therefore, x plus 4 cannot be 0, which means that's another way of saying that x cannot be 4, because it cannot be negative 4. Because if x was negative 4 plus 4 is 0, so then we got a problem. So remember that. So this is just a side note, okay? X may not be negative 4, whatever it might be. So knowing that, now we can solve this thing. What we're gonna do is put the common denominator as x plus 4, like this. Okay, the first one is the only one we have to work on. So to turn this thing with x plus 4 on the bottom, as always, with fractions, what we do is multiply by the same thing on top, x plus 4, because then, as you can see, you have the same thing top and bottom. You can cancel this out, and then it will be 2 again, okay, if you were to cancel out. But we need to expand it right now. So we leave it that way, and then minus 3, okay, x plus 4. And that equals to x plus 2 times x over x plus 4. Now at this point, you notice that the denominators are the same, which means the numerator will be equal, and we can just ignore the denominators in order to solve for x. So we have, we'll write that down. So 2x plus 4 minus 3 equals to x plus 2. And therefore, we have the multiplication again, okay? That we'll multiply with the first guy, that will be 2x, plus multiply by the second guy, that is 8, minus 3 equal to x plus 2. And so we'll gather up the x, being that 2x are on this side. I want to move all the x's to that side because there's only one x here. That way my x stays positive. But you can move it over here if you want. It doesn't make any difference. Okay, so we have, so I'll write down the 2x, 2x, okay, and then this x will push it to the kick it to the other side by switching the sign. This is positive, okay, and if nothing's there, it means it's positive, and so we'll switch it to be a negative. So I took care of the 2x and the x here, and then this over here we have plus 8 minus 3. That's plus 5. So we'll kick the plus 5 onto this side. It becomes a minus 5. And I'll write down the plus 2. So now we have 2x minus x. That will be equal to x. Okay, and then minus 5 plus 2, that's minus 3. So that should be our right answer. And what problem is that? 17, am I right? Yep. That's what the book says. X is not x equal to minus 3. And the book specifically also mentioned that x doesn't equal to negative 4. And that's why. Anytime you see the denominator, x in the denominator, you have to automatically stress that the denominator cannot be 0. But x is negative 3 anyway, so it's not negative 4. So we're good. So let's look at the next problem. So here is problem 19. We have, see, the problem, we have x on the bottom, which makes it slightly harder, but it is the same thing, which makes it slightly easier. Okay, so the only thing we don't have x is this thing. So we'll multiply and we'll put that right in there like this. We have the first term already has everything, so we'll keep it that way. So 3x, x minus 1. The second term, we have just 2, so we'll multiply and divide by the exact same thing, which is x minus 1. The reason is because if you cancel this out, you end up with a 2 back. So this thing holds. And then the third one, we'll keep it that way, okay, x minus 1. So we have this situation. And then being that the denominator is the same in all three terms, now we can just ignore the denominator and let the numerators be equal. And so we have 3x plus 2 times x minus 1 equals to 3. And then we'll multiply this thing out. Okay, this is a parenthesis, so we need to multiply this out. We have 3x plus 2 times x, and then, okay, with each guy, 2 times minus 1, that is give us minus 2, and that equals to 3. And so we have, next we will add up the x's. The x's are all on one side, okay, so we don't have to push them to the other side. So we'll add them up. So this is 5x, which takes care of the 2x plus 3x. We'll push the net minus 2 to the other side, okay, so which becomes plus 2. Anything, you push it to the other side by reversing the sign. And then so 5x equals to 5, right? 3 plus 2 is 5. And then so I'll push the 5 down to the bottom, which means x equal to 5 divided by 5, which is 1. Okay, just push it down across the equal sign to the bottom of the division line. Now, is that right? What problem is that anyway? 19. Okay, 19 we have x equal to 1. Now there is a problem though, because I should mention earlier that the denominator cannot be 1. Okay, so the condition for this answer is the denominator cannot be 0 is what I meant. So x minus 1 cannot be 0. That's one requirement of this thing, which means if you push 1 to the other side, the inequality sign works the same as the equality sign. If x minus 1 cannot be 0, that means x cannot be 1. Okay, but we just figured out that x is 1, so now what? It means that this condition holds first, okay? Because x equal to 1 will make make you divide by 0, and that is not gonna happen. So therefore, this solution that you just found is rejected, and so the answer to this problem is there is no solution. Okay, that you actually have to write it that way. What does the book say? Yeah, same thing. No solution is the answer, the correct answer to this problem. The reason is the only x you were able to hunt down is 1, and that is already kicked out before we started. So there isn't a solution to this particular problem. That is, there is not an x that you can plug in here that will make this equation hold. Okay, it doesn't matter what you think of. It is not going to work. So that's what no solution means. All right, so one more problem. So finally, we have come to problem 21. We have x, and then 5, and then 2x. Well, what's the least common multiple or something? That would be 2 times 5 times x, okay? So in other words, 10x is what we're shooting for. We'll make the denominator into 10x because everything can become it by multiplying a suitable number. So to make this thing into 10x, I'll write down 10x. Okay, what will make this 1 over x becomes 10 down here? Well, we'll have 10 up there. See? That way when it cancels out, it becomes 1 over x. All right, so next, 1 over 5, we need it to become 10x. For that to happen, we'll need 2x on top, see? Because 2 cancel out the 10 will become 5, and then x will cancel out, so then you get 1/5 left. So that's how that works. And then finally, we have 2x. To become 10x, it only need to multiply by 5. So we have 3 times 5, which is 15 up here, and 2x becomes 10x. This is 15, okay? So now that we got the denominator to be the same, the next step then is for us to ignore the denominator, okay, and only focus on the numerator. So then 10 then equals to 2x plus 15. Now in that case, we have we'll do the same thing we've been doing, right? Let me see. Is that right? What is 21? Yeah, it looks okay. Anyway, so we have 2x here. We'll kick the 15 to the other side, which write down the 10. So the 15 is a plus. Kick it to the other side, switches the sign to be minus. Okay, all you have to do is just switch the sign. And then now it's on the other side, which is equal to, this is still 2x, and the other side, minus 15 plus 10 is minus 5. And then the next step is we'll draw the division line and push the 2 across the equal sign down to the bottom. Okay, and so we have x here, and then this will be equal to minus 5 over 2, which is equal to minus 5 over 2 is, well, minus 5 over 2. I think that's it. Yep, that is the answer. Okay, so that is how we do problem 21. And then let me repeat to say that the solving equations is extremely important. And please understand every single step, how it's done, and remember it. If you cannot remember it, however, then please put this section, that is the 2.2 part 1, okay? Not the other half. The other half is, if you forget it, is not surprising, or even the rest of the book. But this section is the most important part of algebra, in my opinion. Not if we don't count chapter 1, is that you need to know it really well. And if you do have problems remembering all this stuff, then please write it down in your notes so that you can refer to it and put it on the top page of your cheat sheet, so that you can refer to it anytime you need it, and you're going to be needing it all the time. So that marks the end of this section.